Now our next question, that is a block diagram. So with the help of a block diagram, briefly describe an arrangement for the transmission and reception of message signal over distance of several thousand kilometers. So schematic arrangement for transmitting and receiving a message signal, it is given in the figure. So in the figure, a microphone is indicated. That is, transmitter has basic parts like microphone, modulator, amplifier, and an antenna. And the other part, that is the receiver, it has got tunable amplifier, that is noise will be removed, then demodulator, that can be transistor, then it is audio amplifier, that is a loudspeaker. So these facts are there in a schematic arrangement of the transmission and reception of the message signal. At the transmitting end, a microphone converts the sound signal into time-varying electrical signal called the message signal. With the help of modulator, the message signal is translated into radio frequency range. The radio frequency is nearly 10 to the power 13 Hertz. The message signal is translated into radio frequency range. The power of the modulated wave is boosted by suitable amplifier. Power means rate of doing work or rate of consumption of energy. So power of the modulated wave is boosted, that is increased by suitable amplifier, and then the wave is radiated into space from an antenna. At the receiving end, other antenna picks up the waves from different transmitting stations. A tunable amplifier can selectively tune in the boost up the radio frequencies, that is 10 to the power 13 Hertz and some other frequencies from a particular station. The original signal is recovered by using demodulator, that is, which is separating audio signal from the carrier signal. After being amplified, the electrical signal is converted into sound signal by using a loudspeaker. So loudspeaker amplifies the sound, and we find that loudness is directly proportional to amplitude square. Well, our next explanation is about the message signal. Now, how to explain about the message signal? It is defined as a single valued function of time that conveys the information and which, at every instant of time, takes a unique value. Signals can be analog or digital. Now, what are analog and digital signals? That is, we have to clarify and we have to give some examples. Now, we come towards analog signal, a signal in which the current or voltage varies continuously with time and is called analog signal. So, analog system is in the form of a sine curve. Figure represents a simplest sinusoidal varying analog signal. That is, V is the voltage of the signal, A is the amplitude of the signal, and omega t is the phase angle. So, A is the coefficient of sine omega t, rather A can be known as the displacement amplitude. So, analog signal is indicated in the figure. That is, from O the signal starts, voltage varies in the positive Y direction, and the signal current is moving on X axis. So we find here that signal is in the form of sine curve. The upper portion is called the crest and the lower portion is called the trough. The upper portion is positive amplitude and lower portion is a negative amplitude. That is the minimum amplitude of the signal. That is the analog signal. That is always in the form of a sine curve, or we say it is sinusoidal varying analog signal. Now we come towards the digital signal, a signal in which current or voltage can take only two discrete values is called digital signal. So two discrete values are important. A digital signal can take only two values. One of them is 1 and other is 0. In the square wave shown in the figure, a signal of V represents signal of 0. V represents binary 0 and signal of 5V represents binary 1. Once more I will repeat it. In the square wave shown in the figure, a signal of 0 volts 0V represents binary 0 and the signal of 5V represents binary 1. Thus, the digital signals are in the form of pulses of equal level. So here the digital signal is indicated and the voltage is taken right on the y-axis, and the varying currents, that is the signal, is taken on the x-axis, and t represents the time instant of the signal when it is recovered.